Now the next chapter that we are going to do is your sound. Chapter name is sound. Very important because lot of questions come every time and there is very fixed set of pattern of questions that come from the sound chapter. Okay. Now, very simple. Now, what is a sound? It is a form of energy. It is obviously neither be created nor be destroyed. Sometimes statement based question comes. How it forms? Obviously, with a periodic motion. Periodic motion is to and fro motion. Okay. And it is also called oscillations. Okay. It is also called vibrations. All words have the similar meaning. Vibrations, oscillations, cycles. These all words, mean similar. That means repetition. Periodic means any motion that repeats itself. That is called periodic motion. Remember. Clear? Got it? Any motion that repeats itself is called periodic motion. Okay. Now again
Yes.
the example is given here, like band vibrates. Okay, sound produced, stop vibration, sound stop. Simple. Sound is strictly produced by vibrating objects. Sound is produced by vibrating objects. Okay. Next, again in our voice box is there that also vibrates. Okay, it is just muscular flaps. You can say the opening and closing of flaps. Wind goes in and out that produce sound by the vibration of the muscles, the cartilage, the voice box that it is made up of. Next, again, the like different types are there. Okay, the like whistling village is there, Kong Tong. Every person has a unique tune name composed at birth. Okay, just for your understanding, because why it is mentioned. Actually, these facts are mentioned in the latest NCERT, so they can pick any of these facts for you. I'm telling you, any fine day, and give it in examination. ठीक है, और कहाँ से आएगा? ऑब्वियसली बात है, एनसीईआरटी में था तो आ गया, बिकॉज न्यू एनसीईआरटीज आई है 9th क्लास की. सो अगेन देयर इज सर्टेन अपडेशन इन द कंटेंट. Every chapter there is something new. Okay, in every chapter. ठीक है जी. Next again vibrating, like thongs. ये example ध्यान रखना. ठीक है, against a rubber pad. ठीक है, a prong of vibrating tuning fork touching the surface of water. Okay, that also vibrates the water molecules. Vibrating prong touching a still water surface instantly generate outward ripples. Remember these things. Observation. This is the experiment. NCERT based experiment. Also points to ponder, listing out of vibrating parts. Flute में क्या होता है? Air column. When you blow the air, that produce sounds. That because that blowing air produce vibrations inside that flute, which produce sound. Guitar string, tabla membrane. Keep remember this each and every part. I'll show you previous year question. After this chapter, we'll do previous year questions also. Okay. Then conclusion, the prongs are physically displacing the water. Obviously, this proves the visible mechanical vibration of the fork is the source of acoustic energy. That means obviously the sound is there and sound is produced by the particles, the vibration of particles. That's why there is transfer of energy here. And that transfer energy is from prong to the water molecules. Prong is nothing, it's kind of a metallic U-shaped bars. Okay, prongs, these are called prongs. See, okay, these are prongs. So again, that shows that it is because of vibration of particles, and vibration of particles holds energy and the energy transfers. Next, again, can sound be produced in vacuum? No. Is there any sound in space? No, because space do not contain particles. स्पेस में पार्टिकल्स नहीं है भाई. ठीक है, तो जो अगर पार्टिकल्स नहीं है तो ऑब्वियसली बात है वहां पे साउंड प्रोड्यूस नहीं होगा. ठीक है. नेक्स्ट, अगेन दिस इज द बेल एक्सपेरिमेंट. ध्यान रखना, As the vacuum pump sucks out the air, ringing bell sound becomes fainter and fainter until it is completely silent. Completely silent means there is no particle. No particles means no vibration, and no vibration means no sound. Sound cannot propagate in vacuum. Again, important facts. It requires a medium like solid, liquid, and gas. And again, if you see if I see the increasing order of speed of sound, speed of sound. Can you tell me? Sound travel fastest in tell me. Sound travels fastest in. You guys don't know. Solid, liquid, and gas. Why? The reason. Why the reason? Because obviously particles are there in both of the mediums, but here the particles are closely packed. Closely packed. So if you see, if I ask you which metal has the fastest speed here, that is the aluminium. Remember. In liquid, if I say, you guys tell me, sound will travel fastest in a salt water or a distilled water? Tell me, which do you think? In a salt water or distilled water?
Salt water.
Obviously. Why? Because particles are closer. It is denser. It is denser. Now, what is the point of having denser? Denser means particles are close. If particles are close, the transfer of vibration. Listen this carefully. I'm using very precise words. The transfer of vibrations is easier in a salt water because of its density as compared to a distilled water. Okay, so remember, in gas, hydrogen is the lightest and sound travels fastest in hydrogen. Why? Because the particles of hydrogen or molecules of hydrogen have highest kinetic energy. Remember here the reason. The reason here in case of gas is not density. It is because of the very high kinetic energy of the hydrogen particles. Because a smaller sound creates a larger amplitude of vibration and the larger transfer of energy. That's why in hydrogen sound travels fastest than any other gas, although hydrogen is the lightest gas. Remember this thing. Okay, so yes, it is the hydrogen. Now outer space is a near vacuum without air particle to collide, transfer energy. Space walking, astronaut hammering metal produce zero audible sound to nearby partner. Remember. Okay, because again there is no particle, there is no vibration, and if there is no particle, no vibration, there is no sound. Very important. Then waves. Sound waves is a disturbance moving through a medium. Obviously sound wave is nothing, it's a disturbance. Remember one very important thing, why it is called a wave, a disturbance? Because because a vibrating particle, whenever a particle vibrates, it's just transfer the energy from one particle to another, one to another, and another and another, like this. It is the transfer energy. Remember, particles of the medium do not travel. The particle here does not move here, it remains at this same position. The only thing that moves actually is the vibration or energy or disturbance. They vibrate at their mean position. They vibrate at their mean position. If you remember, we have done movement of pendulum, isn't it? Remember where we talked about potential energy, kinetic energy, and again potential energy at the different positions. You remember? Yes or no? Tell me. Like this is the mean position. These are called extreme positions. Remember? Guys, respond. Yes or no? Arey, yes or no? If you don't remember, just
Yes,
tell
sir.
me. You don't know, remember. Tell me.
Yes, sir.
You remember?
Yeah.
Okay, good. Now, obviously extreme positions. Now here also, what is happening? the pendulum is revolving around its mean position. It's just moving around mean position, going from this position back to mean, then another extreme, then again coming back to mean position. These are called vibration. This is the same vibration pattern followed by the particle. Followed by the particle. Remember, this is very important line here. Next, again, piston and piston experiment is there. Compression and rarefaction. Obviously, sound, whenever sound produce, some particles come closer to each other, creating a region of compression. Compression is a region of high pressure region, high density region, because pressure because particles come closer to each other. Rarefaction is nothing. Particles come go wider, density become lower, and particles spread apart. Tell me, clear? Clear, yes or no?
Yes, sir.
Okay. Then again, obviously, there is a successive rarefaction, compression, rarefaction, compression, rarefaction. This is how sound moves. The question comes from these statements. Remember these statements. And this is also a wave propagates a series of alternating C's and R's. What is C's and R's? Compressions and rarefactions. Travel away from the source. Remember this thing. Any doubt till now? Any questions? Any confusions? Any doubt? Simple? Simple?
Yes, sir.
Okay, next. Now, types of waves, very important. Longitudinal waves and transverse waves. Longitudinal waves, very interesting thing. The particles are vibrating, let us say vibrating in this direction. This direction is left, right, left to right, left to right, like this is the vibration. And the movement of the wave is also left to right. See, the direction of the particle vibration is also from left to right. And the wave propagation is also from left to right. Both are parallel to each other. Such a waves are called longitudinal waves. Example, sound waves are longitudinal waves. And we have covered earthquake already in geography. If you haven't or if you forgot, just go to the recordings and watch P waves. P waves in earthquake are also longitudinal waves. That's why, if you remember, we have covered one thing in geography, that P waves travel in solid, liquid, and gaseous medium, because they are longitudinal. Longitudinal waves require a medium. Remember. Now, next, transfer waves. Transverse waves, light example. Particle is moving up and down. The motion of particle is up and down, but the propagation of wave is left to right. So they are making a 90-degree angle. The motion of particle is up and down, the vibration of particle is up and down, and the propagation of wave is left to right. Both are making 90-degree. Whenever they are perpendicular, the vibration and the propagation are perpendicular. Such waves are called transverse waves. Example, light waves. Example, light waves. Clear? Any doubt?
Yes,
Any
sir.
question? Okay. Now, light waves, and remember one more thing, few more examples related to physics. All electromagnetic waves are transverse waves. Electromagnetic waves. All electromagnetic waves are transverse waves. Remember. Okay. Now, what are the electromagnetic waves? How to remember? I'll give you a code to remember all EM waves, which the code is JUXU. GXU UVIMR. That's it. GXUVIMR. Jaxuvimar. Okay, that's it. Just remember this word. G for gamma. G for gamma. X for X-rays. U for UV. V for visible. V for visible. And visible contains VIBGYOR. Visible contains VIBGYOR. I for infra. Infrared. M for micro. R for radio. R for radio waves. Now tell me, we have covered light chapter. There also I told you, VIBGYOR. VIBGYOR. This is the order of increasing wavelength. This is the order of increasing wavelength. And this is also Jaxuvimar is also order of increasing. I'll write it here. Increasing wavelength. That's it. Remember, wavelength and frequency are inversely proportional. I'll cover this formula here also. So whenever the increasing wavelength is there, so it is decreasing frequency. So it is decreasing frequency. Okay. If it is increasing wavelength, that means it is the order of decreasing frequency because they both are inversely proportional. And one more trend, one more relation. Sometimes they ask in exam, energy is directly proportional to frequency. Remember, energy is directly proportional to frequency. Remember. Okay. So now tell me, or I will tell you something. Then you will tell me one thing. Radio waves. Now, if this is the order of increasing wavelength, I told you this is the increasing wavelength. This is the order of increasing wavelength. That means longest wavelength is radio waves. If longest wavelength is radio waves, that means it has least frequency. If it has least frequency, that means radio waves contains least energy or the lowest energy. True or false? True or false? Guys, true or false? Yes. Is it true? Did you understood or shall I repeat it? Tell me. Guys, am I audible to you?
Once again, can you repeat once?
Once again, yes, definitely. Just ask me, I'll repeat it. Don't worry. See, this Jaxuvima, that means this gamma, X-ray, ultraviolet, visible, infrared, micro, radio. This is the order of increasing wavelength. And the relation between wavelength and frequency is inverse relation. So if it is the increasing wavelength order, that means radio waves have the highest wavelength. Yes, because it is an increasing order. That means less to or lowest to highest. So highest wavelength is radio. If wavelength is highest for radio, frequency will be least. If frequency will be least, energy will be least. True or false?
Yes, sir.
Now got it?
Yeah.
It's totally fine. If you don't understand in one go, it's totally fine. It's absolutely fine. Just ask your doubt. Okay. But again, don't be in doubt or don't be in confusion. Now more example for transfer waves. More example for transverse waves. In earthquake, remember S waves. We have covered S waves, secondary waves. These are also part of transverse waves. Okay. Again, transverse waves do not require any medium. Remember. But longitudinal waves definitely require a medium. Transverse waves can travel without medium. You can also say this thing. Okay. Then obviously water waves. Water waves or ripples. Water waves and ripples, remember. Water waves, or you can say it ripples also. They are also part of transverse waves. Okay.
Yes, sir.
Okay, good. Now, some waves are also there, like you can also say we have covered, like in earthquake, relay waves. Relay waves are kind of relay waves, or you can say these ripples. Relay and ripples, water ripples, they are actually both both comes under category of both longitudinal and transverse. Both longitudinal and transverse. They are sometimes they are also termed as, you can say, circular or elliptical waves, remember. So now the question can ask, which of the following waves comes under both longitudinal and transverse waves? So obviously if one of the an option is water waves or one of the option is relay waves, so yes, that is the right answer. Okay, but separately, light waves, electromagnetic waves, water waves, relay waves are comes under transverse. Water waves and relay waves comes under both. Sound waves, primary waves exclusively comes under longitudinal waves. Understood or not?
Yes.
Any doubt or anything you want me to repeat? Clear?
Yes.
Okay, good. Now mechanical waves, again a different category also. Mechanical waves. So mechanical waves are longitudinal waves? Yes. Non-mechanical waves are transverse waves? Yes. So mechanical waves require a material medium, sound, longitudinal wave. Non-mechanical medium, no medium required, light, transverse wave. Understood? One more category.
Yeah. Yes.
Okay. Next. Again, the transfer of energy. See, like if you see, like you are hitting a plate or any vessel, when you start hitting, the vibration from this plate and this vessel start vibrating the substance present here. So that shows that sound is a transfer of energy, not mass. Particles do not move, energy propagates. Energy moves from one place to another, not the exact particle. Similarly, again a question for you. Compression, rarefaction move through the medium? Yes. Individual particle move forward with the wave? No. Particles do not move. I'm repeating this multiple times because there is a previous year question. I'll show you. Okay. So make sure you remember this. Next. Real world applications, microphones, sound energy, mic diaphragm vibrates, converted to electrical energy, speaker. Remember. Okay. Then cone vibrates back to sound energy. See. What you need to remember? Uh, you can say sound energy, mic diaphragm vibrates, converted to electrical energy. See, this is for your understanding. Do not get confused. Mic converts, in simple terms, I'll write it here. Mic converts sound energy, because you speak in mic, you speak sound energy to electrical signal. Electrical signal. Speaker, cone vibrates, that means electrical signals back to sound energy. This is the working of speaker. Clear? Understood microphones and speakers, how they work?
Yes, sir.
Okay. Next is, you will hear a word here like, uh, like subsonic, supersonic, transonic. Okay. So what does it mean? Because this is a very common term in aircrafts, and in in terms of defense also, you will hear a lot of these words like supersonic, subsonic, transonic. Okay, so I'll give you the complete understanding. Like, what does it mean? There is a term that is called Mach speed. Have you ever heard what is Mach? Have you heard this word Mach? What is Mach?
No, sir.
No.
No.
Okay. Wait. Now see. Mach is nothing. It is, you can say, calculated, or you can say it is called Mach number. Okay. It is nothing. Mach number. I'll give you a formula. Mach number is nothing. It is equal to speed speed of object speed of object divided by speed of sound.
Is it maximum speed of aircraft?
Which Mach? Which this Mach number?
Yeah.
No. It is a range. It is a range. It is a you can say parameter to calculate the speed of aircrafts. Right?
Okay.
Like for
Yeah.
example, your motorcycle and car speed are calculated in kilometer per hour.
Yeah.
Similarly, aircrafts are very fast. We cannot calculate them in we calculate them, but the numbers will be very high. So we calculate them in terms of Mach, which
Yes.
is comparatively easier way to calculate the speed of aircrafts. Okay. Now clearly understand. Mach number is speed of object divided by speed of sound. It is a ratio. Tell me. It is a ratio. Speed of object and speed of sound. This is your Mach number. Now tell me, if I say Mach, now there will be three conditions. There will be three conditions. Either Mach number is greater than 1, either Mach number is less than 1, or either Mach number is equal to 1. Either Mach number is equal to 1. Okay. Now there are different ranges. There are different ranges. Whenever Mach number is less than 1, wait, I'll write here. If Mach number is less than 1, if Mach number is less than 1, okay, or sometimes it is, you can also say like 0.8, okay, on an average, then the speed is called subsonic. Then the speed is called subsonic. There are subsonic aircrafts also. We have subsonic aircrafts which obviously move less than speed of sound. And what is speed of sound usually? Usually you can say the speed of sound is that we take on an average is approximately 300 meter per second. So it varies, like sometimes 334 meter per second is also written. Sometimes you can say 274 meter per second also written, depending upon the temperature, because obviously different temperatures have different speed of sound. But for understanding the concept, I'm taking this average value, that is 300 meter per second. If the aircraft is obviously moving with less than 300 meter per second, remember, then obviously it is categorized as subsonic. Obviously at that point the ratio will be less than 1. Okay. Now if it is close to 1, let us say it is equal to 1 or approximately equal to 1, okay, then it is categorized as transsonic. Just remember these terminologies. They can ask you what does it mean, what kind of range they are fall. Okay, equal to 1 or approximately equal to 1, that are called transonic. Now if I say it is between, when Mach is between greater than 1.2 or 1.3, but less than 5 Mach. 5 Mach means 5 times the speed of sound. 2 Mach means 2 Mach means it is your uh, 2 times the speed of sound. So Rafael that we have, Rafael, its speed is 1.3 or 1.1.35. So it comes under category of this range. What this range is called? Supersonic. But if this Mach go beyond 5, then it is called hypersonic. We have hypersonic missiles which are faster, 5 times faster than speed of sound. So you can imagine how fast that missiles get launched and move. 5 times the speed of sound. Hypersonic missiles, hypersonic aircrafts. Okay, so this is called hypersonic. Understood every range? Any doubt in any kind of range? I'll repeat it. Tell me. So again, for a defense aspirant, these things you should know. Okay, supersonic, subsonic, transonic. Remember the range. They can ask you match the following base question on that. Like which category of sound falls under which range of Mach. Mach number is just a comparative number with the speed of sound of the object. We compare it with speed of sound. Remember, this is the formula. And again, different less than 1 subsonic, equal and approximately equal to 1 transonic. From 1.2 to or you can say 5, obviously supersonic, and greater than 5 hypersonics. Now your homework, write it down. Your homework, you need to write it down. You need to write it down for your homework. Again, current affairs, defense. That as a defense aspirant, you should know. Write it down. Supersonic aircrafts. Name of supersonic aircrafts. Name of supersonic aircraft of 3 countries: India, Russia, and US. Okay, two names. Latest generation. Two names of each country: India, Russia, US. Similarly, hypersonic aircrafts. We do not have hypersonic aircraft, but Russia and US have. So Russia and US hypersonic aircrafts. List two names, two names, 3 names. How many? Whatever they have. So make sure you write hypersonic aircrafts for Russia and US. One more question. Hypersonic missiles. Hypersonic missiles of US, Russia, Iran, Israel, India. Write it down. Hypersonic missiles of US, Russia, India, Iran, and Israel. Done, or shall I repeat?
No, sir, done.
Done? Clear? So this is your homework. Write it down, make the list, and share in the group. Clear? Proper notes by tomorrow. Clear?
Yes, sir.
That is your homework. Next. Now let's go to the waves now. Okay. Compression and rarefaction we already understood. I told you that waves move with the movement of particles. Wave move with movement of particles. Okay. Now waves move with the movement of particles. Then they form obviously the waves, and waves are called two parts: crest and trough. Crest and trough. And these crest and trough are nothing. Crest, the region of maximum density, compression, and trough is kind of rarefaction. And what is a wave here? Wave is, remember, crest plus trough. Wait, I'll give you the definition of wave. What is a wavelength here? When you talk about wavelength, how you calculate wavelength? Number 1, crest plus trough is a wavelength. crest plus crest is a wavelength. Third, trough plus trough is a wavelength. That means two successive crest. The length of two successive crest from here, you can say from here to here is a wavelength. Two successive trough from here to here is a wavelength. And one crest, one trough. One crest, this one. I'll give you this example. One crest, one trough. All are lambda, lambda, lambda. That is called trough. Oh, sorry, that is called wavelength. What is crest? Compression. Comparative to compression. Compression, rarefaction, compression, rarefaction, crest, trough, crest, trough, crest, trough. Trough is minimum density, rarefaction. Particles are apart from each other. Okay. Then this is obviously a plot of density changes over distance. Okay. Again, dense representative. We understood that thing. Okay, that is not so important. But again, the point is here to understand compression and rarefaction in parallel. Again, they can ask a question based upon these diagrams. Did you understood the meaning of wavelength? Tell me. Yes or no?
Yes.
Understood?
Yes, sir.
Okay. Next. Again, wavelength. See, these are the wavelength, long wavelength, short wavelength. Obviously. Okay, wavelength distance between the two consecutive crests or troughs. I told you these all are wavelengths. Crest, trough, crest, crest, trough, trough. Remember. Frequency, number of density oscillation at a fixed point per unit of time, or I'll give you a simple. This is the NCERT line. I'll give you one more simple line. Number of vibrations or oscillations or cycles in per unit time. In per unit time. That is called frequency. Now tell me if I say yes, and it obviously it is unit is hertz. Now if I say the frequency is 10 hertz, can I say there are 10 vibrations in 1 second? True or false? If I say 10 hertz means one vibration, number of vibrations of it, sorry, 10 vibrations. 10 hertz means 10 vibrations. Yes. Per unit time means 1 second. In 1 second. Yes or no?
Yes, sir.
Okay. Can I say it 10 oscillations in 1 second? This is also true. Or can I say 10 cycles in 1 second? All definitions are correct. Question for you. A particle vibrates 240 vibrations. A particle vibrates 240 vibrations in 40 seconds. Can you tell me the frequency of this particle? If a particle vibrates 240 vibrations in 40 seconds, 240 vibrations in 40 seconds, what is the frequency of this particle? Right?
6 hertz.
Huh? How much? So obviously 240 divided by 40. How much? 6 hertz is the frequency of this particle. Because what we need to calculate? We need to calculate in vibration in 1 second. If we know the vibration in 1 second, it is nothing. It is the frequency only. This is not frequency. It is just a vibration in 40 seconds. To calculate the frequency, we need to calculate in per unit time. Remember this thing. Per unit time. Time period is nothing. Time period is time taken for complete one oscillation. One oscillation. Time period to complete one oscillation. Now, what is the oscillation? What is the oscillation? Let us say this is the position O, this is position A. Particle moves from O to A to O, then O to a position B, another extreme position, and coming back to O. This is called one oscillation. This is called one oscillation. And whatever
Yes.
time is taken to complete the one oscillation is called the time period. And frequency is nothing, it is reverse of time period. That's why hertz is also called second inverse. Okay, got it?
Yes.
Okay. Now, why it is called one oscillation? One oscillation is the time period, or why frequency is 1 upon time period. I'll give you one more mathematical reason here. If I say a particle completes one oscillation, if a particle completes one oscillation in 30 seconds, one oscillation in 30 seconds, that means according to this formula, frequency will be 1 upon 30, isn't it? Tell me. Frequency will be 1 upon 30. True or false?
True, sir.
Got it? Obviously, whenever it says one oscillation, it is the time period, and time period is related to frequency that has an inverse relation. So we need to know the time period for one oscillation. Now, if I say a particle do 10 oscillations in, let us say, 0.5 seconds, 10 oscillations in 0.5 seconds, what will be the frequency? So 10 oscillations, or even if I write vibrations or cycles, meaning is same. 10 oscillations in 0.5 seconds. Yes. So one oscillation will be in 10 by 0.5. Sorry. If 10 oscillations 0.5, so one oscillation will be 0.5 upon 10. That means 0.05 seconds. Tell me. 0.05 seconds.
Yes, sir.
And if one oscillation is in 0.05 seconds, so frequency will be 1 upon 0.05. How much? It will be 20 second inverse or hertz. Isn't it true or not? Tell me. My calculation is right. You can check also.
Yes, sir.
Correct? Understood or not?
Understood, sir.
Okay. If you getting it, I'm telling you, it is the core concept of sound. Means if you understood this, you can solve any question of sound chapter. Any question, I'm telling you. Again, concept. If you understand anything, if you want me to repeat, I'll repeat it. It's totally fine. Okay, don't be in doubt. But
No,
I
sir.
hope
Clear.
you understood the calculation step by step what I did here. Correct?
Yes.
Okay, next. Good. Now again, how to measure? This is just for your understanding. Okay. Again, read my phone also release radio waves. Frequencies are there. Everyday sound contains mixture of frequencies. A pure single frequency sound can be created by tuning, fork, or whistling. Just remember these examples. Sometimes they given options also. Okay. Then again, there is an app that is called 5fox. You can also try this app. The 5fox NCERT mentioned है, तो मैं लिख दिया यहाँ पे. ठीक है. Audio spectrum tool है. You can listen your sound waves exactly. Okay, so very interesting app. You can try this. Okay. Now frequency and like pitch and loudness. Pitch and loudness. Very interesting. Very important. Remember, pitch is nothing. Pitch is related to frequency. That means, see it written here. Pitch frequency determines pitch. Pitch means that sharpness in voice, like voice of no cry of a baby, infant. That is high pitched sound, very sharp. Okay, and usually females and women have a very high pitched tone, high pitched sound because of the sharpness that they have. Okay, don't take it in a negative way. Okay, don't take it in a negative way, but that is scientific proof. Okay, that women have high pitched sound. Okay, that is quite sharp voice. Okay, so that is determined by frequency. They have high frequency. Females, infants have high frequency. That means frequency is proportional to pitch. Higher is the frequency, higher will be the pitch, and higher will be the sharpness in the voice. Frequency means obviously higher oscillations. Again, basic concept. Higher oscillations in 1 second. Obviously, that is called frequency. So higher frequency means more number of oscillations. Now, if I give you example, there is an object A and object B. Object A produces 100 hertz. 100 hertz is too much. Like 20 hertz in 1 second, obviously. 20 hertz of frequency, obviously. And another object is 25 hertz. Now tell me which of the following object is high pitched sound, produce high pitched sound, A or B?
B.
Huh? Okay, B, obviously, because of high frequency. This B have high pitch. Now if I modify how UPSC modify question sometimes, I am taking again A and B. I say object A vibrates. Object A vibrates 400 times. Object A vibrates 400 times in 40 seconds, and B vibrates 500 times in 25 seconds. Which of the object has higher pitch? Again, a level of difficulty. You understand the level of question that I have asked you right now. And this is the topmost question, highest level of question that they can ask from this topic. Object A, again I'm repeating, object A vibrates 400 times in 40 seconds. Object B vibrates 500 times in 25 seconds. Which of the following object has the high pitch? Again, some calculation. We need to calculate in 1 second. Let us calculate in 1 second. So in 1 second, it will be around 10 hertz. Tell me, the frequency will be 10 hertz, yes or no? Frequency will be 10 hertz. Correct? And here it will be 20 hertz. Because we need to calculate for 1 second. So 1 second it will be 400 by 40, 10 hertz. And here it will be 500 by 25, 20 hertz. Obviously high pitch. High pitch. Understood or not?
Yes.
Understood.
Understood, sir.
Good. Again, this is the highest level that they can ask. Okay. And again, amplitude determines by loudness. Loudness, how loudness related to amplitude? Again, remember the relation. Loudness is directly proportional to square of the amplitude. Again, NCERT. Unit of loudness is, anyone knows? You have
No,
covered.
sir.
Decibel. Decibel यार पता है तुमको, भूल गए हो बस. Decibel. Loudness की unit क्या होती है? Decibel. ध्यान रखना. Depends upon the amplitude. Directly proportional to the square of the amplitude. Remember the relation. Again, a question for you. If I double the amplitude, if amplitude is doubled, does loudness become 4 times by this relation? Yes or no? Yes or no?
Yes, sir.
So these are the questions that they can ask you. Got it? Any doubt? Any confusion? Anything you want me to repeat, I'll repeat it. Tell me.
No, sir. Nothing.
Varun, understood?
Yes.
Okay, good, yeah. Again, let's move. Sound energy we already covered here. We have done. Okay. Just revisit these things. Okay. Then crescent row we already covered. Okay. This thing also already covered. Same slides are there, but right now here amplitude and intensity. Amplitude is the maximum displacement. See amplitude. See the waves. Maximum displacement from its mean position. If this is the mean position, if this is the mean position, so the displacement here. Just observe the displacement. If this is the mean position here, if I can draw this, wait. If this is the mean position, you can see the displacement of the particle from its mean position. So that is called amplitude, remember. High amplitude, low amplitude. Higher the amplitude, louder is the sound. Louder is the sound. Intensity. What is intensity? Intensity is nothing. It is just a sound energy passing through a unit area. Remember the difference. Definition based difference is also very important. Remember. Okay, where also you can remember this fact. C.V. Raman studied the acoustics of Indian percussion instruments like tabla and mridgam. Okay, so you can use this, learn this fact also. They can ask. Okay, it is NCERT, newly NCERT. They introduced this scientist based facts also. Okay, then what is the tone? Single frequency. Single frequency. Example: tuning fork. Single frequency sound. Note is a mix of frequencies. Instrument produce mix of frequencies. Different frequencies are there. And what is a timbre? A unique quality of sound. The syahi, the black patch on a table. See, this is on tabla. The black patch on tabla alters membrane vibrations for rich tonal control. That is called timbre. See the level of content they have increased in NCERT, and truly I appreciate whatever new NCERTs they have included the syllabus. It become more detailed. If you take interest, you will learn a lot of things around you. So see timbre, the black patch on tabla is actually because it changes the frequency, changes the quality of sound by altering the vibration of the membrane. Isn't it interesting? Tell me guys. I hope you are not getting bored here. Tell me. आर यू अंडरस्टैंडिंग? समझ में आ रहा है?
Yes.
बताओ भाई. Okay. So amplitude and intensity are cleared. Anything you want me to repeat? All clear?
Yes, sir.
Tell me. Good. Again a question. See 10 density oscillations at given position. Calculate the frequency. Obviously 10 density in 2 seconds. So frequency will be obviously 10 by 2, 5 hertz. We already did this kind of numerical. What is the time period? Obviously time period is reciprocal of frequency. Reciprocal of frequency, even if you do t is equals to 1 upon f. So t is equals to 1 upon 5. It is also 0.2. You can calculate by this method also, and obviously by this formula. See this numerical. What this graph says. Again, this is a graph. it holds certain important locations like 25, see 50, 25 to 50. This is one crest. Obviously, if one crest is 25-meter, wavelength will be 50 or not? Tell me. Graph based question, guys. UPSC love these kind of application based question in physics. And if you got the obviously the wavelength, again the formula for that. What you need to remember? I'll just tell you. There is a formula that wavelength into frequency is equals to speed. Remember, this is the formula that they are using here. See, okay, this is the same formula that they are using. That's it. Understood? Clear?
Yes,
Tell me
sir.
any doubt,
Yes, sir.
because I'll give you questions right now. We'll solve previous year questions. Don't worry. Okay, I'll give you questions. Okay, so make sure you ask your doubts if you have any confusion and any doubt. Clear? Any doubt? Any confusions? Any questions? Tell me, guys.
No, sir.
Sure. ठीक है. Again, frequency is oscillations by time. This time period is time upon. See, remember this formula also. It is also helpful. Sometimes data is given based on these formula also. Okay, so make sure to remember these formulas. Okay, see, oscillation upon time is frequency, and time upon oscillation is time period. This is reciprocal of this. That's why frequency and time period are reciprocal of each other. Logic. Okay, next. This is the formula. Okay, again, speed of sound, steel, 5,000. Okay, and water, air. See, this is we take 344 in 22 degrees Celsius. Does speed of sound change if frequency changes? No, remember. Okay, again, this is the data at 15 degree, remember. Okay, so remember these values because they are NCERT mentioned values. This is the formula that we have covered right now. Wavelength into frequency is equal to speed. That is the simple formula. Now range, obviously ranges are there. Okay, audible range, ultrasonic, infrasonic. Okay, so these are the no types of ranges. Like here also you can see the numerical. Human hearing roughly spans for 20 hertz, 20k hertz. The uh, some misprinting might be here, but worms ears 20 hertz. Wait, this is kind of misprinted. Don't worry, I'll add it. I'll add the question. Some misprinting is there. Okay. But if I say what they are using here, okay, I'll just replace this question. Don't worry. I'll give you a separate PDF. Okay, I'll just give you a separate PDF. In that you will find these questions. Don't worry. Okay. And similar type of questions are there. We'll do in previous year question. I'll show you. So infrasonic, audible, and ultrasonic sounds. Remember the animals again. They are NCERT based animals, and the sources they have given. So make sure you learn at least these, so that you can eliminate an examination. Okay, NCERTs are basic. You need to remember the things that are mentioned there. Okay, audible range, pitch or shrillness is driven by frequency that we already know. Okay, range less than 20 hertz, 20 to 20k, and more than 20k is dogs, bats, and dolphins can produce or hear also. Okay, then echo. What is the echo and reverberation? Very interesting fact. Okay, in cinema hall or in auditorium, The concept of reverberation, that means multiple reflections causing persistence of sound. Persistence of sound. That means because of multiple reverberation, the sound holds, increases. Okay. And that actually cause a lot of sounds. So yes, auditorium covered with a lot of sound absorbing panels, porous surfaces, curtains in auditorium, so that the sound do not reverberate. Do not go for multiple reflections, because it can do overlapping of different frequencies. That's why. What is echo? Echo is again returning of sound. Remember, returning of sound after single reflection. That is why there is a difference between a echo and a reverberation. Here we are focusing on single reflection. It is multiple reflections. Now, facts about our brain. NCERT based things are there, facts are there, you need to know. Brain retains sound for 0.1 second. What does it mean? That means, what is the concept of hearing echo? Echo means, if how when we hear echo, when we say something loud in mountain area or in some area, like we hear our voice twice or multiple times. That is the voice going from our, that means the source from us to an obstacle and coming back to our ears. Okay, that is the time period that our brain retains the sound. It retains the sound. So the sound should return within 0.1 second. So if you take the average or normal speed of sound at 22 degrees Celsius, 344, and you calculate the distance, that means to perform a echo, to have a echo, to hear a echo, this is the minimum distance. Minimum distance for sound travel. But but the source, the source and the obstacle, must be separated by a minimum distance of 17.2 meter. That's why it is written as 17.2 meter. Because from source to obstacle, if the distance is less than 17.2, the sound reaches early. That means early than 0.1 second. Then there will be no echo. We are not able to differentiate between the two sounds because our brain cannot hold it for a longer time. Okay. Similarly, if you see the minimum distance as per our brain's limitation, the minimum distance between a source and obstacle is 17.2. From this they can also ask a question from me. Any doubt regarding echo? Because we'll do numerical related to that. Tell me, any doubt? Tell me, guys, any doubt, any confusion? No?
No, sir, no doubts.
Okay. Next, now see. A clapping in corridor is greater form of, you can say, form of echo. 2 round trip, or you can say it take 0.23 seconds. Okay. They can, if the total distance calculation, what is the and with the problem is, wait, this question is also incomplete. Wait, I'll check and add this question. Give me a second. Because this is important question, I'll tell you. Yeah. Wait, I'll write the question here. Okay, leave this question. I'll write it here. or I'll take a separate page. I'll delete it. I'll add a page. See. Now the question is here. You pick up your pen and notebook. Solve with me. To clap in a. No need to write the question. Just write the values and solve it. You clap in an empty corridor and hear echo after 0.5 seconds. Okay. If the speed of sound is 340 meter per second, calculate the distance from the wall. Calculate the distance from the wall. Calculate distance from the wall. Now see, it is a very basic speed distance time formula. That's it. Distance equal to speed into time. That's it. Speed into time. Distance equal to speed into time. That means 340 into 0.5. What is the answer? It will be 170 meter. Now, can anyone of you tell me what is this 170 meter? For your context, I use the speed of echo. This is the speed of echo, and I use the time period of echo. Can you tell me what kind of distance I have got? If I use the speed of echo, if I used time period of echo, then what is this distance?
Also, this distance would be means towards the wall and coming back.
This right, exactly. This distance is traveled by echo or sound. True or false?
Yes, sir.
But what they asked a distance from the wall. That means this is the source and this is the wall. The distance that we calculated here is 170 from going and coming back. But they are asking only one side distance. So what we need to do? We need to half it up. This is the distance from wall. Understood?
Yes, sir. Got.
Got it? Got it? Now I'll give you one more question, but for the homework that you will give me. Okay, you have to send me the homework for this. I'm writing a question here for you. Sure, I'll take. Mm, an echo is heard is heard an echo is heard after 0.4 second. An echo is heard after 0.4 second. Okay. And if the speed of sound is 340 meter per second, calculate the distance traveled by the sound. Yeah, echo. Got it? Clear?
Yes.
Okay. So this is the homework question for you. We'll do. Okay. Okay. Next. Infra audible we already covered. Just make sure you know the examples. Very simple examples, guys. Okay. High frequency ultrasound penetrates matter deeply, making it ultimate non-destructive testing tool for industry and medicine. Remember. Okay. See the types of sounds and their uses are important. These are NCERT based. Okay. Make sure you learn this. Okay. Now bats obviously use ultrasonic sound to catch its prey. Okay, to calculate the speed, distance, time, waves reflect of prey or obstacle. Okay, brain commutes time delay to determine exact distance and direction and in absolute darkness. See how this brain works. Very smart and very accurate. The calculation of speed, distance, and time. Just sending the sound waves. So you can imagine that how their brain are been made. Okay, so it is very interesting thing to like they do at night because they cannot see, it is just sound, and by emitting that sound they can also imagine the size of a tree, the width of a tree, the size of the prey, the speed, the distance, everything is being calculated by just sending the sound and receiving it. You can see that how smartly their and how uniquely their brain works. Okay, remember this example. Again, sonar system, very important. Sound navigation and ranging, full form is very important. Worked upon same concept of echo. Okay, releasing the sound and going back. See, formula is 2d into v into t, again to check the depth. Why it is twice of the not twice of the distance, but you can say the v into t, again giving the same velocity of the sound, time period by the echo. So distance is nothing, v into t by divided by 2. What that we did here. See, v into t divided by 2. Same thing. Same thing. V into t divided by 2. Again, the distance between the object and the ship. This is how it is calculated. Okay. Audio surveillance, again, drones produce, because drones, again, latest technology, the drones produce low frequency hummings. Sensitive sound sensors can detect the beyond visual range, where you cannot see drones, but these drones again can detect them. Sensitive sound sensors can detect those hummings, low frequency hummings. Okay, range of airspace security. Again, question C. A naval sonar signal sent into seawater returns in 0.9 seconds. Speed is this. How far is the object? Obviously, you calculate speed into time. You can see they did something different, but the meaning is same here. Either you half the time and multiply it, then also you will get the answer. But if you do like this, even if you solve like this, like 1530 into 0.9, okay, what it will be? It will be 1530 into, if I say 0.9, it will be 1377 meter. This is nothing. This is the distance traveled by a echo. That's it. Just half it. You will get 688.5. Same answer. Answer will be same. Why they half the time again? Because if it is the echo is taking the 0.9 time, so obviously one way time will be 0.45. This is one way time. One way going from source to the obstacle. See, again a question. Understood? You can do it either way. There is no rule of it. Ultimately, you need to understand. You can do the any way of calculation, whatever you understand easily. Okay, sound is now being used to record Mars, measure ocean temperature shifts, track biodiversity via soil acoustics. Physics you learn today build the tech. Obviously, again the examples are also where sound is being used here. Got it? Clear? Understood?
Yes, sir.
Okay, so we are done with the chapter. Okay, I'll show you certain questions. Few questions we'll do here. Rest of will be homework to you. Come on. Chalo bhai, aa jao. Solve. Karna jara. Now you guys tell me the answers. Okay. Remember one thing, one basics. Lambda should be in meters. Speed should be in meter per second. Keep the units in mind. Okay. Now solve.
The 2 seconds.
Varun, is a how long? How long means time period. Now time period means distance equal to speed into time. Okay, if I calculate speed, I have distance that is 1000 meter. If I calculate speed, I will get answer for t. Yes. From where I will calculate the speed? Obviously from here. From here. I have lambda. Yes, 0.2. Do I have frequency? Yes, 1000 hertz. Can I calculate speed? Yes, 200 meter per second is equals to v. So it is 200 meters. So time period will be, wait, I'll just put it in charge. Now, so time period will be 5 seconds. Sanvi, understood?
Yes, sir.
Varun, got it?
Yeah.
Okay. Next. Now, see, question number 90. Yes. Which of the following cannot be unit of frequency of a sound wave? Tell me. Very simple, guys. Decibel,
D1.
dB. Decibel is unit of loudness. It is not unit of frequency. All these are correct. These can be unit of frequency, but this is not. Now next, beats is the phenomena that occurs frequency to harmonic motions. Even if you don't know, just write. Remember, nearly same frequency, not equal. Nearly same. Remember, okay? Nearly same, or sometimes it is written as slightly, slightly different. Slightly different or nearly same. Remember, not equal. Next. Next.
Yeah.
Correct. Obviously, big all persistence, repeated reflections, reverberation. Okay. Next, not correct. Read it. It is NDA previous year 133. ND.
These.
Hmm. Sound waves are transverse waves. Obviously, they are longitudinal waves. This is incorrect. So option B is correct. Yes. Next.
A.
Hmm. Obviously, sound is longitudinal, light is transverse in air, obviously. Next, see, everything will be revised from this previous question and the practice. That would be enough.
D.
Hmm.
D.
Questions? D. Frequency is related to pitch is related to frequency. Yes, D. Again, I told you frequency is directly proportional to pitch. Remember this thing. Next. This is a good question. You need to understand the meaning of the word here. If you understand, you will be able to answer it. And also the meaning of the question, the understanding of the question.
B.
B.
Yeah, B. Distance.
Yes, good. See, actually, what is amplitude? Amplitude is nothing. Amplitude is displacement. How? Displacement of particle. Even in the definition, what we said a maximum displacement of particle. Obviously, it is calculated in terms of distance only. So yes, it is measured in units, units of the distance. Okay, B is right. Next, sonar. Sonar, which kind of waves? See, if you haven't seen, I'll show you. See, which kind of wave is being used here in sonar? Ultrasonic waves. Clear? Everything will be in PDF. We have already discussed these things. Ultrasonic waves? Yes. Clear? Next. 146 NDA. These both are NDA PYQ. Okay. Okay. Wait. I will give you a glimpse of this ear structure also. I think I have missed by chance. Yes. Okay. Remember this ear structure also. Okay. Eardrum and cochlea, where it is located. Okay. Never mind. I'll tell you here only. 146. Question number 146. Which is not correct. Remember, not correct.
Should be part.
The speed of sound waves in air decreases with the increase in temperature. Yes, that is wrong. It actually increases. So it is the right option. Rest of things are right. Now, the part of human ear that converts the pressure vibrations associated with the audible range. Actually, it is, see, the working of cochlea. I will explain you the human ear. Listen it carefully and you can make notes right now also. Okay. Sure. See, first, obviously, when you talk about eardrum, understand here. Or I will write it in the PDF. I'll write it here. Okay. See. Now, if you talk about eardrum is nothing. It is a vibrating. It is a vibrating membrane. It is a vibrating membrane. Okay. And this eardrum is also called, the other name for eardrum is called tympanic. Tympanic membrane. Okay. Then there is a, after this eardrum, obviously this is called your outer, this is your outer ear. Okay, or you can say this part almost like your some part of auditory canal. Okay, and the outer part this is called ear is called pinna, and this is a part of outer ear. Then from eardrum to this part, almost your middle ear, middle, and this is the remaining part is your inner ear, part of your inner ear. Okay, now the differences. Tympanic membrane we already covered. Now in this middle ear, these parts, these are the important bones here. In the mid, these bones and these bones, they actually help in amplification of sound. Whatever vibrations are there, there is a amplification of sound. There is a three bones. It is called hammer, anvil, and stirrup. And stirrup. Okay, remember. And their collective work is to amplification of vibrations. Amplification of vibrations. Now in the inner ear, it is the cochlea. Cochlea. First part is your cochlea. Okay. Inner ear is also called, you can say, labyrinth. Labyrinth. Okay, it is your cochlea. Remember, cochlea actually converts, you can say, waves, or you can say waves slash vibrations to electrical signals because they are connected with nerve cells. Electrical signals. Now there is a term that is called Eustachian tube that I haven't mentioned here. Eustachian, which is part of middle ear actually. Part of middle ear. I'll write it here. Eustachian tube. Okay. Eustachian tube. Eustachian tube actually maintain you can say air pressure, maintain air pressure. Okay, with, you can say, air pressure between ear and throat, because it is actually connecting with your throat. Okay, air pressure between your ear and the throat. That means both sides of your ear, like this side also and this side also. So it's Eustachian tube. It is somewhere connected here. Actually, it is connected here. Okay, so it is help in maintaining the air pressure on both sides. Now let's come to the question here. The part of ear that converts the air pressure variation associated with the audible sound to the electrical waves to electrical signals. Now the main word is here, audible sound waves to electrical signal. Obviously, copy. Understood? Clear? Clear, guys? Yes or no?
Yes.
Okay, next. See again, same question, repeated question. Pitch depends upon fast. We already covered this. Pitch
D.
depends upon
D.
frequency. Yeah. Next. See, frequency of alternating current is 3 Hz. What does it mean actually? Again, definition of frequency. What is the meaning of frequency? It means 3 cycles per second. 3 cycles per second option B. Okay. Then again, flute is not correct about flute. That's why I told you. See the PDF. Everything is there. We have covered. Tabla, flute. Wait, at the beginning only. Yeah. See, flute has air column. Okay. See, flute. Let us see. Comes. Not correct. Sound comes from vibrating column inside. Yes. Sound comes from the vibrating column air inside as well as outside. Obviously not. So one is incorrect here. Okay. See, one more thing. In order to find out, like, or you can say in case of eliminating the options, obviously two opposite options cannot exist together. Okay. Two opposite options cannot exist together. So obviously the flute, actually it is the air column that is forming inside the flute. So this is the correct. This is also correct. This is also correct. This is also correct. But they asked not correct. So obviously it will not come from outside. There is no air column outside the flute. Vibrating column is inside the flute. So this is not correct. Clear? Next. Echo. Solve this fast. Fast, guys. Last question. Remaining will be homework to you. Okay.
Sir, 850 meters.
The distance between, yes. Do we need to halve the distance? Tell me.
Sorry, sir.
Do we need to halve the distance in this question? Yes or no?
Yes, sir, we need to do so.
Yes. Okay. So obviously, again, distance equal to speed into time. Speed is 340, time is 5. You will get 1700. This distance is actually traveled by a echo, but they asked the distance between cliff and the person. So we need to half this distance. Okay. 850. 850 meters. Next. Read it carefully. We already covered this. I think rest of questions are simple. Yeah, I'll give you remaining our homework actually. Come on, complete it fast. जल्दी simple है बहुत यार ये तो. Microphone converts sound to electrical signals. Yes. Speaker converts electrical signals to sound. Yes. 2 and 4 are correct. 2 and 4. Yeah, D are correct. Yes. This is wrong. This is wrong. Next. This will be your homework. Very interesting. See, actually, no. I'll tell you this question. I'll explain this question. Very interesting. This is latest. Actually, came in CDS 225. Very good question. I'm telling you. See how the level of question they are asking, and you can also get this question anytime. Now these questions will be related to your previous motion chapter and work energy. Make sure you solve these questions. I have attached some questions that are the latest previous year questions in NDA and CDS. Okay, so make sure you solve this. I'm explaining this question. Very interesting, very unique question, very different question. See, a sound wave traveling at a speed of 330, okay, produce 20 crests, 20 throws. See, if I make a wave One crest, one trough, two crest, two trough. That means one crest, one trough together make one wave or not? Tell me. One crest or one trough together make
A
one
wave.
wave?
Yeah.
Yes or no? Right?
Yes.
Similarly, if I pick one crest from here, one trough from here, will form one wave? Yes. If I pick 20 crest and 20 troughs, how many waves? 20 waves.
Yes, sir.
20 waves, obviously.
Yes.
And they ask the wavelength. And they ask the wavelength. Now, see, a sound wave traveling at a speed of 330 produces 20 crest and 20 troughs in 0.1 seconds. So if I use distance equal to speed into time, I have speed, I have time period here, okay? And this is the distance. 330 into 0.1. Answer will be 33 meter. Answer will be 33 meter. And they have asked wavelength of a sound wave. Wavelength means one sound, one wavelength. See again, core definition. One wavelength will be one crest, one trough, right? Because question is one crest, one trough. That's why I'm taking this. Otherwise, crest plus crest, trough plus trough is also wavelength. But as per question, crest and trough are there. So one wavelength will be one crest, one trough. This distance, tell me, is equivalent to 20 waves. Tell me. This distance will be equivalent to 20 waves. Isn't it? Yes or no? Understood this thing, what I have said? Varun and Sanvi, did you understood what I said right now?
Yes.
Are you getting me? Because this is the distance traveled by a wave with a speed of 330 in 0.1 produced 20 crest and 20 trough. That means with the speed of this, in a time of this, they produce 20 waves. Isn't it? True? Correct? They produce 20 waves. Now, if I calculate one wave equal to 33 by 20, that means 1.65 meter. And one wave is nothing. It is actually the wavelength. Because one wave includes crest plus trough. See the level of depth of the concept. This is your CDS 2 2025, and I can expect that they can ask this type of question in NDA 2 2026. Maybe, because this is a very good question, I'm telling you, and they can repeat this type of level of question in NDA also. And it happened multiple times. It happened in the past also. Whatever question they asked in CDS, they put it in NDA, or whatever they asked in NDA, they give it in CDS also. It happened, especially for science and polity. Science, polity, geography. There's a lot of commonness in these subjects actually. Understood this question or not?